Having studied a number of different types of graphs, the job that we've got to now do is to have a look at the characteristics of different graphs or equations of graphs, and then to work out which equations match which graphs or which pictures. So I'm going to show you in this section some of the characteristics that you need to remember. Now, we've looked at three main types of graphs. One is a straight line graph, one is a hyperbola, and one is a parabola. They're the main ones. Now, we have also looked at a couple of others, but we're just going to have a look at these for the moment. Now, if you have a look first of all at linear graphs, these are straight line graphs. There's an example of a linear graph, and they all have this type of equation: y is equal to mx plus b. Now, you will notice that compared to a parabola, there's no power associated with the x. If there's a power associated with the x, it's not a straight line. The other thing to remember is that this section here, the plus b, is where it cuts the y-axis. That's a very good indicator. So in this case, this is a plus 1, and that cuts at 1. So you can always look at the end of the equation to work out where it cuts the axis. Of course, the other thing is to look at the slope, m. If it's a positive slope, you know that a positive slope goes this way, and a negative slope goes this way. So if there's a negative value there, it would be going the other way. So there's your straight line. Just a few things to look for. What about parabolas? Well, parabolas have got a squared value. So if you've got a question with a square value, it's definitely going to be a parabola. Now remember, parabolas can go this way or they can go down. And we did a bit of work with this sort of thing. If they're going up like this, it's because there's a positive value before the x. So the number before the x is positive. To go the going down like this, you'd have something like y is equal to negative 2x squared or something like that, but there's a negative value in there to go down. The other thing is that the plus 1 here works in a similar way to the straight line. It's where the point cuts, so that if it was a minus 1, it would cut down here. So you can move the graph up and down. So there are two things. Just reviewing again, if it goes this way, it's because the value is positive here, and it cuts at 1 because that's 1. So if it's negative, it will go down, and once again still cut depending on what the number is at the end of the equation. Now, hyperbolas are broken up in the sense that there's a line on this side and a line on this side, and it never cuts the y or the x axis. And remember, the reason for that is that if you've got this sort of equation and you substitute in x equal to 0, 1 over 0 is just undefined. You'll get an error message in your calculator. It just doesn't happen. So that's why it doesn't touch. So you're looking at an equation with either the y here and the x here, or remember, you could have had x equal to 1 over y, which is very less likely, and sometimes they're written xy equal to 1, so that you could just move the x down if you needed to. So if you divide both sides by x, they cancel out and they give you what we had here. So remember, y up here, x down here, and you've got the line broken into two. We'll call it discontinuous. All right, and the final one that we're going to have a look at this stage is called the exponential graph. And this is where the x is in the power, as in up here. So whenever you get this situation, the line goes up like this. And so that's what you've got to watch for. All right, now let's have a look at a situation where you've got to use this information to decide which graph matches which equation. So I'll just pause this for a minute, and we'll get a value up for you. All right, now here's an equation, y is equal to 3 over x, and we have to decide which of these four graphs it matches. Now I think if you look carefully at this graph here, you can see first of all that you've got this form of equation. So we know that it's definitely going to be a hyperbola. This would have an equation something like this, and this one is a straight line, which would be maybe something like this. So you can see this one matches either this one here or this one here. Now the question is, which one is it? And there's a couple of things that we can look out for. Well, first of all, we've got to find out which of these points works well with this equation here. And I'll show you what I mean. In this particular case, we've got a point sitting on the line 1 and 1. So what we're going to do is we're going to take those values 1 and 1, and remember that's your x value and that's the y value, and we're going to substitute it in to y equal to 3 over x. So we're going to substitute. Okay, so we substitute 1 and 1 into y is equal to 3 over x. And you see what happens when we do this. Okay, so they're both, x and y are both 1. So this is what we get. So when y is equal to 1, we get 1 on the left-hand side. And when, yes, that's right. And when x is equal to 1, we get 3 over 1. Is 1 equal to 3 over 1? And the answer is no, 1 is not equal to 3. That does not work. So those points there do not work for this equation here. Whereas if you take 1 and 3, so we'll look at these points here, 1 and 3. Once again, we've got x and y sitting here. We're going to substitute 1 and 3 into y equal to 3 over x. And so let's take our value of y, which is 3. And let's take, there's our 3 over our x value is this one here, which is 1. And you can see that 3 is equal to 3. So that's a true statement. And because this was a false statement, then this one cannot be the right graph. But because this 1 and 3 works, it substitutes in and makes a correct conclusion. Left-hand side is 3, right-hand side is 3, so it must be right. Then this one definitely is our solution.